The next challenge for the HackPack IR Turret was to add a distance sensor, and we're going to take a few steps further by coding in a Sentry Mode and adding the Neopixel ring here. So far, it's been helping me lose weight, helping with parenting and defending my Oreos, and slowing down the in-laws. Seriously though, I love my in-laws. This was a fun one, but first we need to print our sensor mount. The product page supplies the STL files to print your own mount for the distance sensor. I modified the supplied STL file to make it a little larger. Insert the sensor, and I'm going to secure it with one of a million hair ties I can find in my couch. Screw it into the mount shown, and in a second we'll cover the wiring already done. Plug in red to power, black to ground. I have orange for trigger to digital pin 7, echo to digital pin 8. Plug in your USB cable and we can write some code. Everyone starts with a good tutorial, so let's follow Adruino's. We need to define trigger pin 7 and echo pin 8. Create a duration and distance variable with our globals. Use pin mode to set trigger as an output and echo as an input because we're sending a command to trigger and expecting results from echo. We'll want to listen for the high trigger, and it's recommended we wrap that in short, low power triggers. Then we can read the duration the high trigger took. Since we know it's the speed of sound, with a little math supplied by the tutorial, we can get the distance. When you run your code and enable the monitor, you should see your distance value. To make sure this works, let's prototype a Sentry that fires when the distance changes significantly. Don't worry about the details here since we will rewrite this after moving to the Adruino IDE. If our arm distance is 0, then we need to set the distance. Otherwise, if our current distance is double that of arm distance, then fire all the darts. To add the NeoPixel LEDs, we'll have to add new libraries, but we can't do that at the moment in the CrunchLabs IDE, so we need to migrate to the Adruino IDE. First, copy and paste your existing code and paste into a new sketch in the Adruino IDE. Let's compile and fix issues as we go. The first issue is that we don't have a microcontroller specified. Click on Select Board, we know it's COM3 from the other IDE, search and select for the Nano. Our next error is that the pin definitions file can't be located. The HackPack Discord has this available to download, and from one of the examples, paste the file into the same location as our sketch. Finally, the IR remote file can't be located. This isn't provided by CrunchLabs because it's a free library we can access through Library Manager. Click Install, and that should be our last error. When compiling and uploading, I see the IR turret reset, and our distance readings are coming through. We're ready to add some LEDs. We want the ability to arm the turret instead of always on. First, create a boolean for the arm state. We'll want to reuse our distance code, so move it into its own method and clean up the unused distance and duration variables. Create the arm and disarm methods, which update the armed variable. Next, create armed distance as a global variable. In the arm method, set arm distance to the current distance by calling our new distance method. In the loop, we need our logic before the switch statement if we intend on returning before allowing the user any input. In my example, we'll fire all when the object in front has doubled its distance. Compile frequently when you're able to do so, and address any bugs along the way. Finally, create the hashtag command in the switch statement that arms and disarms our turret. I have a NeoPixel ring with 12 LEDs. I've soldered wires to power, ground, and signal in. We won't be using signal out for this project. Connect our power and ground to the breadboard, and I'm using digital pin 2 to keep it simple. I'll just double-sided tape it to the bottom. First we need the NeoPixel library. Then include the library in your project from the sketch menu, then include library and ADA Fruit NeoPixel. Define the NeoPixel pin, the number of pixels, and the brightness. Then we'll initialize the LEDs as the variable pixels. As shown, include the number of pixels, the pin, and the documentation has recommended values for its type plus speed. If your LEDs have a white subpixel, then you should use GRBW. Otherwise, omit the W. We need to use the begin method before anything else, and we can set our brightness here too. The fill method will assign the color input to all LEDs in that object, then use the show method to update the LEDs. In ARM method, we'll use the same show and fill, but instead use a for loop to break up the 3-second pause and iterate through each LED with the set pixel color method. Remember to compile and fix your bugs. Now when we arm it, we'll get a small countdown, fire all the darts when it's moved, and reset to the disarmed state. If you like what I'm doing here, be sure to subscribe.